Welcome to Novatr Architecture Stories, where we dive into ideas, technology, and people shaping the future of architecture. Today, we are thrilled to be joined by Ken Clausen, Head of Digital Practice at 3XN, a practice at the forefront of digital innovation and sustainable design. From turning their Copenhagen studio into a digital twin with real time climate feedback to leading the computational design behind the breathtaking New Sydney fish market, Ken brings a rare blend of creativity and technical depth. Welcome, Ken. It's a pleasure to have you on our podcast. As an architecture nerd myself, I'd love to start by asking, can you tell us a little bit about where you are sitting today? Just paint a picture of that beautiful framework behind you.
To do a short introduction to this office here, as you can see, it has these timber structures all around. So this is the office by night from outside, where we really can see these 5 distinct gunboat houses that are connected together. And on both right and left side, there's also many of these with other architectural studios. But in this case, the office here on the left side was how it looked before, back in days when they were building the boats and it came to the edge. And this is then our office on the right side and how we have opened it up. So we really interact with both the light and the water in here. I don't want to go too deep into detail, but I think one fun thing just to introduce us a little bit the technical things of how we see us as a company is when we moved in here, we of course used all of our skills when it comes to technologies because we had an opportunity to create basically a digital twin of this building here. So this is a simple section of the office, and over here on the left that I'm called Facade North. And as said, when you have the opportunity to work on all of those models and tools, you have the opportunity to begin to have another look at your building, because usually you enter the door and then you are part of the space. So you never get this kind of overview of the space. And when you then look into the digital model, suddenly you can see all of these interesting combinations being revealed. You can see how the meeting rooms are placed here in the back. And then up in front towards the water, we want the most people to enjoy the view. And that's kind of how we see this space. So when you enter here, you have the broad look around the space. And then from there, you can find your way into your spot and position. Experiencing a transformation space from the good, the bad, and the ugly side. Because when you live in a space like this, you cannot suddenly rotate the building because you want to have a better wind or sun condition. You have to kind of accept that there's also some days where you basically can't see your screen because the space offers so much more. We go in and look at the location, and then we get like an overview map of where is it located, and get static data on how this area is working, how the sun and wind path is. Just very, very simple. What we then do is that we have our building, and in this case, our building is locked in the position. So it gives us some answers to how the sun is moving, how the wind is moving and affecting our space. But what we then do, and what we did in this case, is that we took all of those simulation tools and techniques and used it on our space, and started to trying to figure out what is happening here. Because sometimes this, for example, this slide here shows that from within 2 meters in this space, in really hot summer days, there can be 2-degree difference. And we sometimes see the ones sitting close to the water, and the ones up here at the other end, there's sometimes 5-6 degree differences. And all of this is part of how this space here works. You need to find strategies on how you can, in some way, get wind and get ventilation into this, natural ventilation into this space, but also ensure that there's no draft. You need to get nice daylight into the space, but as shown here, it's maybe a little bit of a tricky simulation. But if you see this iPhone image up here, you can basically see a sun shade, direct sunlight coming in, and it's hitting the screen. So everything here that's red actually means where the screen is failing. So there's times a day where the office honestly have issues with how do you shade on the screens. But we have set a rule out that we want all of our tables to be oriented in a way where you both are part of the space, but you also have a water view. And that's quite amazing to look at those tools and see what that provides for us. But we have gone even more nerdier to it, and I'm afraid that it's already going too much nerdy into the things. But this is static. This is static data. This is data that everyone has available and can go out and download and use. And this is really good and open source. But the issue here is that static data gives you the history going backwards in terms of how the world has been performing, sun, wind, all of that. But when you live in a space like this here, you basically need to understand that an office space like this has almost local climate zones from being at one end to the other end, because it is so tricky as a space when it comes to wind and sun. So we have placed in what we call dynamic data sets, which is sensors that collects data on how the space is working. It looks like this. We call them airbirds. It's a product that we created some years ago now that sits around in the space. You can see an airbird here, 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 and they are multiple places. And they measure CO2, they measure temperature, they measure humidity. But how can you navigate in this every day when we are so different? And this is what the airbirds are doing for us. They are telling what is the temperature here, what is the humidity, should I turn up or down, or what should I do? And all of those heaters here, they also have sensors in them. So suddenly it's becoming one big sensor map. A second thing we did for the office is that in this case, we installed also ventilation systems that now also runs on real-time data. And this means that the data that we again receive from those airbirds and those heaters makes us able to save almost 80% of the ventilation costs, because we are now running again on real-time data. So it's not just pressing play and letting it air constantly. It adjusts to the space, how many people we are there, and so forth. And I don't want to go nerdy into things and how that looks when you look at data platforms. It was a long introduction from analog to digital, but it was just to highlight a little bit of how this world here is working today, both for us and for the industry, and also what I see when I'm out either presenting or hosting workshops for schools or at conferences, that there's an interest in looking at both data insights, but also how do you use them actively to do something in your either process or your buildings.
I mean, honestly, this is level pro max for me right now. You mentioned it might be getting nerdier, but I think for me and anybody who's watching this right now, it's only getting more fascinating. Building on that, I'd love to shift gears a bit and just take a step back. Just would love to ask you, like, how did you get into architecture? And from there, what led you to the world of digital practice and computational design?
If I start with this can be quite a long journey to explain, so I think I will steal snippets out of my life. But I am from Denmark. I now live in Copenhagen and have a really nice family that I enjoy spending time with, even though this office is nice. There's also other places. But when you ask about my journey and kind of going back to the start, I was thinking a little bit about that lately. This is back in the day, so we are talking 2007, and I realized that's 18 years ago. And the funny thing was that I was sitting and watching a television, and then I saw from the Venice Biennale, that is the architectural biennale that is every year in Venice. I had no clue about architecture. I had no clue about all of these things. I've always liked to game. I've always liked to. I actually was sitting quite early in SketchUp and 3D Max when I was really, really young, just to try it out, but had no context. But this was my start, and then I moved to Aalborg University. That is a school that it's in the northern part of Denmark, and it's a university, which means that you are taught in architecture, but you're also taught in engineering. And for me and how my brain works, that fit perfectly, because I tend to say that I'm both a design solver and a problem solver in one brain. But that's maybe a little bit of a short snippet of the steps, and there's of course many others, but I will leave it at that.
Thank you, Ken, for taking us through your journey. I would just like to sum it up for my viewers here that it really just starts from having a vision or an idea that you want to express. Once you have that, I mean, it's just the next step is figuring out the tools, techniques, technology, or any of that sort that can actually bring your ideas to life. Yeah, I mean, that is amazing.
When I started at 3XN/GXN, our innovation company, we had used, from what I know, a little bit of Grasshopper before, like scratching the surface. But when I arrived, that was a little bit also the idea, moving me directly from the innovation group and placing me directly in architectural projects to see what values could come out of it, How could we go forward from here? And then over time, you learn through experience what becomes important, what do you want to learn, and how can you maybe pivot to different positions. But it's very difficult to explain a direct path, especially when it comes to my path, because I can't really replicate. I can't see anyone replicating that path here, because that path is done. Now we need new talents to show us the next steps of what is there, so we can be provoked and inspired.
Definitely. When we speak about people exploring generative tools or diving deep into, new tech, the path is really straightforward. What really stood out for me was your point where you just have to go beyond any abstract idea and think about what you can bring to the table with these tools that can accelerate, the progress, the longevity, or the overall development of the project. So, Ken, shifting gear a little bit again and asking you about the new fish market in Sydney. Just to bring to your notice that I have been living in Australia for about 6 years. Having said that, I have been hearing about the project since like my student days. I have visited the old one and I'm eagerly waiting for the new one to be finished. Could you tell us more about the project and, of course, the incredible roof, the real showstopper of the project? Yeah, I just wanted to understand more about the project.
I'm super proud that you say that. To be honest, I'm a little bit I'm trying to figure out a little bit where that sits in me still, and it's not only me but a fantastic team that is part of. And as I mentioned, this year is a little bit maybe tricky for the viewers here, but these are some of the backgrounds we have in the office. The architect, the construction architect, the parametric designer, the BIM manager. But suddenly you can also see that the circularity, that was unbelievable. The circularity design specialist, graphic designer, behavioral psychologist, sustainability engineer, and you can go on and on and on. I just dropped a few of those here. They are all part of the workflow we have at the office. And this is something that has been over the years expanded. And you have to start here to accept that we are all in some way digital. And everyone in some way, from the photographer to the BIM manager, are part of the design technology pipeline today. But basically, the new Sydney fish market is what you see here on the screen. It's a huge new, almost new urban area in Sydney, where on the left side you see a little snippet of the old fish market. It sits here on the harbor side, so you get like water in, and all of the boats are coming in here with the fish. You are in contact with the green landscape and park behind, and then you have the flow of the city and the road behind. So you basically have all of these infrastructural things that can happen. You have landscape, you have roads, pavement, and then you have water. And then we sit there with a building that we thought as something where you come in and then you enter kind of a big urban area on top, and then you cover it with a roof that closes it together. Everyone in some way understands what it takes to come up with an idea, and I can understand why it, for especially young architects and your audience here, can be a little bit frightened. I can't say that, but a little bit tricky for them to grasp what it takes to get into an industry where we are showing A and B and not all of the good, bad, and let me not call it ugly, but tricky periods in a project like that. Because this year is 2017. This year is 2025, a couple of months ago.
Wow.
What we wanted to envision was adding a little bit of an extra feature on top, let's say, where you can do so much more. The place becomes an identity on its own. It's a place where you can go and enjoy maybe a swim. You can enjoy the park, but everything is kind of melded together. You are part of the story of that fish and that production. So there's places in the fish market where we basically cut out the floor, and almost as an amphitheater, you can sit and look at how an auction hall actually works. Usually the places where you're not allowed in. So that kind of interference in a positive way between industries and between people, we think could add value to this space here. The question then is, a new world-class fish market, what is that? And this was our proposal, as said, a fish market where you have these amphitheater, big staircases outside from 4 locations where you enter. So below you have the industry, water goes in under as well. And then here on top, you have the roof that covers it all and ensures for everything that we could think of when it comes to climate, what I want to go into later. And I said here below, you have the wholesale, you have the industry working for you. On top, you have cafes, restaurants, offices, places to sit and chill, and then the roof that covers it. And now we highlight it again. I showed everything that you maybe would show in a fancy lecture or online at Arc Daily or wherever. But did it actually give you anything else except just showing the images or the movies? And maybe it did, 100%, I guess. Something has changed when we see this. But we need to move also the industry forward. And that's also to show a little bit the process behind and also how we maybe think and how we were thinking in this process here. So this is examples on how we start a project. It's going crazy now on screen, but it's just what we call process logs. We haven't drawn a building yet. We are just looking at everything we can around that site, the history, the infrastructure, what is a fish market, what is the logistics. So much that has nothing to do with the form and shape at the moment, but more thinking about how a fish market like this could work in a site like this. Being very context specific is one of our key agents in 3XN, that the context describes the building and the people describes the usage of the building as well. And this means that now you saw, let's say, process log 1. And now process log 2 is, now there's shapes beginning to pop up. Ideas are beginning to pop up here. We haven't done any fancy grasshopper technology. We're just sitting in Rhino and testing sizes, beginning to do renders. And remember this, I can see the date is like back in 2017. So we are at another time in life where Inkscape didn't really exist yet, for example, and also other of these fast visualizations tools. But I'm trying to highlight here that a process doesn't start with the perfect. It starts with so many other stories and so many other identities before you can begin to recognize the fish market as it is today. And then from here, it goes into a little bit more clean diagrams. Now we know a little bit more what it should be. And then we take them into, it could be Illustrator, Photoshop. There's so many also different alternatives today where we go directly into to Inkscape and animation. But back then you can see physical models were a thing. So a lot of things happened. And here in the end, you can begin to recognize the shape that came out of it. And now you might ask yourself, well, is that shape curving for fun or for so many other things? And I can definitely tell you, getting into this, that this is not for fun here. I think the curvature here from side is really hitting what we wanted, but there's so many things that makes this roof work functionally that gave us the shape more than just the funky shaping here and there. But basically, we have a roof, if I go back here, where it stands on these steel cruciform columns. And then we have the hybrid timber structure. There's some steel somewhere because of some functions below, but then we have steel joints hidden. And then on top, we have what we call skylights that basically cover the roof from one side and then let natural daylight in from the other side. It has PV cells and everything on top as well, where we have used simulation to place them in the correct orientation versus the sun in Sydney. This is a snippet from the process, just maybe highlighting a little bit that these are some of the things where we explore geometry. We don't necessarily need to look at the full model sometimes. Sometimes we zoom in on things to explore how can water move around on the surface? How can the geometry go from having a lot of different elements to a lot of the same elements? So there's a lot of things here where we begin to explore from, I would say, more a geometry computational understanding, how we can design with a roof and a system like this, because it became almost a design system on its own to develop this system here. And I said, to really break it down, we have skylights on the top, and then we have the structure and the columns here. And inside, this is a finished area in the fish market where you really see those materials come together, but also all of the alignment, all of the subdivisions of the surfaces, everything we actually had in our model as well. So this is really a one-to-one project that moved back and forth. And here we are not alone, of course. We have had amazing people involved. So it's been one big collaboration. But here I'm going to talk about the starting point and all of the geometry steps going forward. So basically today I'm more covering, I would say, the left side here, left triangle, the one with the timber structure, and then the skylight more for performance. And as we start, and always just interrupt and ask questions, so else I just go. So when you do a roof on this side, it cannot be there for fun. We are using a lot of material. It needs to create something and give something back. So of course it needs to create cover. We wanted it to adjust to the program levels below, so you didn't have a flying roof, but it was connected to the spaces below. We wanted it also to help enhance kind of the views here and there. So these were some of the architectural features that we wanted it to be. But what was important for us was that we wanted the whole surface to be collecting all rainwater that comes down, and then that can be reused in both for maintenance and cleaning in the building, but also for making sure that there's enough water for all of the plants and vegetation, everything around the building. And below, of course, the shading device that I showed before, that kind of like skylight, that they both are a shading device. It lets daylight in, it produces energy, and it has a modular production. So there's quite a lot of layers to this project here. And here are some of the things that we went through several times. I will mainly touch rainwater and material optimization here, but we selected different things from that simulation book that could be quite important for the process here for this project. And as said, when it rains in Sydney, it rains a lot. A lot of rain comes down.
Yes.
Where do you get that? Where does that go when you have a surface like that? If we have had a flat surface, we would have issues with getting the water away, and the structure maybe would break, or if it had to be over-dimensioned like crazy. So here on the right side, for me, the one simulation that is running, that was a tool that we developed, and again, we are back in 17. It now exists a little bit more native and generic in it, but you can see here in the end that you have a blue zone and a blue zone, and begin to recognize the shapes of the fish market curvature. And this is where we managed to collect most of the water on the roof, and then let everything down into systems that can be reused on the roof. And that's why it is curved as it is. And also over here, we of course did our design simulation tools, but we needed engineers to verify that it could be done also with the amount. So kind of a link between us and ACOM on that simulation was quite nice. And they also in some way verified that our tool was calibrated quite nicely. And as said, this then became a bigger thing where we began to link all of those water and collections into everything that is around the fish market in terms of vegetation, etc. If we go into how we work with projects like this here, it can become very, very tricky, because where do you start? And we didn't have really a starting point, because the starting point was everywhere. So we started both with having kind of a surface geometry. We had also that building system in mind, and then we also needed to touch on the joints immediately. So there was a lot of things going back and forth here. So if we look at the timber first and the beam that we use, if you look at it like this, you get like the material surface, you get also the EPD, you can get also where it's coming from, you can get the quantities, you can get so much information. But if you turn the geometry glasses on, you suddenly can begin to do even more with it. You can begin to put it into a digital environment. You can begin to maybe test and explore the differences between having a more materialized model and a more digitalized model. And by linking all of this together, we always start very local, as I showed before, with the arena as well. Here we are testing what happens if we begin to work with the system and rotate it. What are all of the angles that we need to adjust and put into the model? So starting very local, just testing one grid to see how it affects when we begin to change it. And we have that local system put in mind. We begin to build systems like this here, where we begin to build hierarchies on how things are put together. So from left side to right side, we begin to look really at geometry, and on the right side, we begin to look more at let's say the render and boundary models. And then we have models that can now do this here. So before we had one that could do one little corner point here, and now we have a model that actually can adjust fully to all of the changes we are making on the way when we now get a new water simulation in, or we have to adjust to yet another office space, or there were so many things that affected this. So that's why we used computational models to run and control this project here, from wireframe model to surface model to geometry model, so to say. And this will bring back to the analog world. One thing is that we can show the renders, but jumping a little bit back and forth is always quite amazing working with these projects. And from top view, a little bit fake, I must say. We have added some steel zones here and here, and some here for the functions underneath. But this is basically the grid from top, really structured, really back to kind of the food, really structured, aligned. I can see the rhythms. I can see almost leaves here, or the systems when you cut a cucumber up. There's so much organization here. But when you
Yeah.
turn it on, I'm a little bit of a soccer fan. It covers 3 soccer fields from top. So it's a huge roof
Oh,
that is 200 meters by 100 meters. So that's what it covers. So it's big elements and it's huge geometries. I'm just flicking a little bit through this to show a little bit more on how we communicate things also in a project like that. Sometimes it's important for us to take snippets out that maybe can be visualized like this, so you get an idea and feeling of what we are trying to do. And then maybe begin to more diagrammatize the elements in the model. And from there, we can begin to, every time we did a new iteration, we got the quantities out, the number of elements, how much material we were using, the length, like all of the usual suspects. And this comes down to using parametric models. This is an old school one. I don't even know if it's valuable to show today, but it's basically because this model here is so heavy and we work with so many different stakeholders, basically. We build up a model that can support that kind of grid model I showed in the beginning. Then we have the structural model that we can send and pass back and forth to the engineers. And then we have one that handles the panels. And that was 3 Grasshopper models. You can see here that works in one. And then we were sharing data between all of us constantly to ensure that we had the light feedback. And this was before Beam and all of those fancy plug and play tools today, which is fantastic they arrived, but back then we had to code it ourselves. But with bringing all of these digitalization in, you have an opportunity to discuss so much more. You can suddenly begin to discuss the materialization, the joints, all of those things that suddenly also are becoming quite important. So this is, for example, an example of a joint and sequencing how you need to put something together so that it's possible to make a roof like this. So now we're going more into details on the joint, and here we are getting a lot of information from Rubner, our the timber contractor in this year, about how they envision it, how they envision the details. So back and forth, this was maybe a big learning from us, that because we have a roof structure that are moving up and down, it affects quite a lot on how you can place beams in this project here. And this also means that our detail was a little bit affected in the end, but we accepted it because that's part of production and culture. And then here again, like coding all of the beams and joints as well.
yeah.
Yeah. And that brings me, I hope, to the end of that quick presentation here. But by working with these models, we are able to connect a lot of these things together in a joint way, which means we have a collection of overview of all of the joints that are in a model like this.
Wow. That was an amazing presentation, Ken. Thank you so much for taking us behind the scenes. Not just the project, but the process, the mindset, the digital craftsmanship that truly defines this future forward architecture. It's easy to admire the final form of a building, but today you reminded us that real beauty often lies in the phases, in the iterations, the data, the collaboration, and the quiet thinking that happens long before the pretty visualization or renderings. For every architect, designer, student listening to this episode, I think it's a very powerful reminder that great design isn't just about big ideas, it's about the tools we use, the questions we ask, and the system we build around them. Thank you so much, Ken, for sharing your journey and your generosity of insight. So, anybody here still listening to this, if you want to learn more about that amazing digital technologies, digital platform tools, ideas that Ken was talking here, please do check out our courses in the description below. Until next time.